All right, so here we are talking about quadratics. So I'm going to do this in two videos. The first one's going to be about factoring, and then the second one's going to be about solving a quadratic equation. So the first thing I want to say is this is super condensed, right? Hopefully in algebra class you did this for weeks, maybe months you spent on quadratics. We're going to do this in one or two videos here. So the big picture here is just like we can factor a number, right? We can factor 6 here to be 2 times 3. We can factor the number 54 to be 2 times 3 times 3 times 3. We're factoring it down into its primes to see what it's made of. Well, we can do the exact same thing with polynomials. And this is really useful in engineering and computer programming. Sometimes you need an unknown changing variable, and we still want to deal with it. We do want to do some math with it. We want to have some physics with it. We want to make predictions with it. So the way we're going to factor this is it will end up starting as something that is, remember the word quadratic here. Oh, we haven't talked about that. The word quadratic comes from Latin quadrado. It means squared. So we'll start with something where it has a variable to the second power. Usually we'll do x. And then we're going to take that apart to be 2x to the 1 powers, right? And we're going to cleverly pull this apart if it's factorable. It's also possible that it's prime, right? I can have a big number like, ooh, can I think of one? 37, right? That's a pretty big number. 36 you can pull apart. 38 you can pull apart. 39 you can pull apart. But 37 is a prime number. You cannot pull that apart into two separate prime factors that when multiplied together make that. So it's possible that a quadratic will be prime, but we're going to practice trying to factor, and then we'll be certain that, you know what, I used my method, this one cannot be factored. Okay? But the end result would look like taking one of these and turning it into two binomial factors. So we've got 1, 2 terms times 1, 2 terms, and we can multiply that back out. Right? We could say, okay, well, x times this, that's x squared plus 4x. Distributing the 3, this is plus 3x plus 12. Combining that, I get x squared plus 7x plus 12. So when I multiply them together, I did get the original. Okay, so big picture, just like we factor a number, we're going to try and factor a quadratic, okay, into two prime things. Then when they get multiplied together, make that product, okay? So a quadratic, as I mentioned before, a quadratic comes from the word quadrado. It means squared or to the second power. So the general form looks like this. Although it's totally possible that one of either the second or the third term could be missing. So I show you a couple other examples. If there was no number or integer at the end there, then we just say, oh, you know what? X squared plus 7x, still a quadratic because it's got the x squared. Or we could have no middle term with the x's. And we could say, well, we still got the x squared, and then we got some numbers. If you want to rewrite either of these, you could say, well, this is x squared plus 7x plus 0. This one would be 2x squared plus no x's minus 1. So you could always rewrite them in that standard form where we have a first, a second, and a third term. And we go in order from the squared to the x to the just numbers, no x's. Okay, so here's our big picture plan for how to factor a quadratic. First, if there's anything that's shared in common by every single term, let's just pull that out first, okay? So in this case, all of these were even, so let's just pull that 2 out. And it's like, I say it's like undistributing, because if we did distribute this 2 in, so if I send this 2 in, I get 2x squared plus 6x plus 10, which is exactly what we started with. So we're just factoring out that 2. We're saying, what did it look like before the 2 got distributed in? Okay. This second one here, we're not just pulling out the 4 they have in common, but we're also saying they all have an x. They don't all have an x squared because this one's only got 1 here. So we can pull out 1x and the number 4. So again, we just divide that out of each term. And we say, well, what's left over other than that? Well, there's a 1. And then out of the 3 x's, we divide 1 out, so there's 2 x's left. This one, 4, we get 2 left over, because 4 times 2 is 8. And out of the 2 x's, we took 1 out, so we're left with an x. The last term, the x's cancel, and 20 divided by 4 is 5. And we just kept the signs the way they were. Okay, so we take out anything they have in common. After we do that, we're going to use the Xbox method to factor our quadratic. The Xbox method will always work as long as, you don't make a mistake. So we don't need to remember 10 different methods, or if it's this case, or this will always work. Now, of course, there are clever shortcuts, okay? And if you want to dive down those roads, great. In this one video, I'm going to go over a background safety net method that works for everything. But absolutely, there's shortcuts, there's other tricks, other teachers teach it in different styles, okay? Now, the Xbox method goes like this. We've already pulled out, okay? So I'm going to write in pink here. We've already pulled out and I'll call it the GCF. That means the greatest common factor. So we already pulled out the GCF, right? So the common factor we've taken out. So this is what we're left. 6 and 13 have nothing in common, and this term doesn't have an x, so every term doesn't have a variable, so there's no numbers, no variables that all of these have in common. Okay, so step 1, we write out all 3 terms in standard form, and we figure out what is our A, what is our B, and what is our C. Okay, they have to be in order from x squared to x to no x's. So A is next to the x squared, B is next to the x, and C is the last number. We absolutely take care of the sign. So this is a -5 and a +13 and a +6. Okay, so we got those squared away. Now what we're going to do is we're going to go down here and set this up, okay? Right down here, I tell you exactly what goes where, okay? We set this up. There's no critical thinking here. We put things in the places where they go, okay? So we take the entire first term, which is 6x squared, and we put it in this box. We take the entire last term, and we put it in this box, okay? So that's where the box from Xbox comes from. First term and last term go in here in the top left and the bottom right. Okay, now what we really want to do now, just to tell you like the kind of big picture goal, the big picture goal is to figure out how to split this middle term up. Because when I multiply 2 things together, okay, and I'll just do an example over here. This has nothing to do with this problem in particular. But when I multiply together any sort of products like this, if I distribute these in, I get 2x squared plus 10x plus 1x plus 5. And then I will combine them, and you will see this with 3 terms, and I'll say, oh, go ahead and factor that. The first step we want to do is we want to go back 1 and say, what did this middle term start as? What 2 things did it start as that when combined left you over with 11x there? So that's the goal of this Xbox, or at least the first half of it. Okay, so let's see. We take over here the product and the sum. So the product is the first times the last. 6 times -5, or A times C, is -30. Okay, so we want to find a number. So we want to find 2 numbers that when multiplied together have a product of 30. And then the sum is just the middle term, right? The 2 terms when combined will make 11. So when we add the 2 terms together, we get the middle term. So we get that 13. Okay, so what 2 numbers are those going to be? Now, we might just guess and check. I like to do it systematically. So I like to go, well, the only numbers that multiply to make 30 are 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, 6 times, so I just go 1, 2, 3, 4, 5, 6, and as soon as I repeat myself, I go, well, that's the end of the list. So it's one of those 4 if it's possible to be factored. And then I also say, well, I know that the product is negative. So that tells me that one of these is negative and one of these is positive. Okay, so that tells me that when I add a negative and a positive, they're going to cancel out. So really I'm looking for the difference between the 2 numbers. So the difference between these would be 29, 13, 7, and 1. So I go over here, oh, the difference was 13. So it's this one right here. And was I left over with more positives or more negatives? Well, I was left over with a positive 13. So that means I had positive 15 and negative 2. So you could guess and check. You can find those 2 numbers however you want. But that's my systematic approach. Okay, so now we've got the two numbers we were looking for were -2 and 15. Okay, so what I do is I now put those over here in these two boxes with an x next to them, because again, the big picture is saying, what did that middle term start as here, right? That 11x was originally a +10 and a +1. Let's split that back up. Okay, what we've just found is this middle term that was 13x was originally a +15x and a -2. So we just took the original equation of 6x squared plus 13x minus 5, and we split it up to say it actually started as +15 minus 2 minus 5. Okay, that's what that goal of the x is. We're looking for those two numbers that combine to make the 13x middle term. Okay, so once we found those two, all we need to do now is say, what do those have in common? So we go, all right, well, I already did it here, but we say, what do these two have in common? They have a 5, and they don't have an x, so it's just the 5. What do these have in common? They have an x in common and a 2. What do these have in common? A 3 and an x. And what do these have in common? 1, which means they have nothing in common, right? The biggest number that goes into both 2 and 5 is 1. And then also, a rule of thumb that you can just always use is the GCF that we take out always has the sign of the first box. So in other words, if this is positive, then this is positive. If this is positive, then this is positive. Again, if this is positive, then this is positive. And if this is negative, then this is negative. So you just keep the sign of the first box. And that's it. That's your product. It's 2x plus 5, 3x minus 1. And we can just double check by multiplying them together and seeing that it works. Okay, so let's do some problems now. The first problems on the homework here are not going to actually have you do both factor out the GCF and use the Xbox method. Instead, it's going to be one or the other. So these first ones here, I like doing it now. Let's not do pink today. Let's do green. So I'm going to look, what do they have in common? So the GCF of these, well, 2 goes into both, 3 goes into both, but 6 is the biggest number that goes into both. And then they both have at least one x, and actually they both have 2 x's. They don't have more than that. So I divide out my 6x squared, and a common mistake here is saying, oh, well, I divided out the 6x squared, so that's gone, and we just get a positive 3x squared. But if you started with 2 terms and you factor something out, you always still have 2 terms. What we're essentially doing is we're dividing out a 6x squared from each of these terms. So you're right that that whole term, quote unquote, cancels, but when you cancel with multiplication, 5 divided by 5, you're left over with a 1. And that would be it for this. We don't know that yet. I'm going to check, but that's actually the answer. Okay, I'm going to rewrite that as 3x squared plus no x's plus 1. I'll say, ooh, that's an Xbox method format. So I'm going to go ahead and do my Xbox, okay? So I'm going to draw my x. My product is first times last, 3, and I'm just ignoring the GCF. I'm trying to separately factor what's inside here, and I just leave the GCF outside. And I'm going to see, it's like having 54 times 3. I could leave the 3 there, factor the 54, and then say, oh, that's 3 times. And then, ooh, 54 is, we just did it up there, is 2 times 3 to the 3rd. So I can factor the 54 and just leave the 3 where it's at. And so this product and this product are still the same. So you can just factor a piece. Just don't forget to have the GCF stay there. Okay, so anyways, the product is first times last. The sum is the middle term. And then I write my box. And I go, okay, so the first term, the last term. Okay, so I'm looking for 2 numbers that have a product of 3. It's positive. So that means either both are positive or both are negative. Okay, and the only 2 numbers that multiply to make 3 are 1 times 3. So 1 plus 3 would be 4. -1, -3 would be -4. Oh, so this is not possible. So what that means is this right here is prime, which means this is completely factored already. So again, we get to one of those circumstances where like the number 37 seems large, like you could factor it, But you can. We just tried. Okay, that's as far as we can go. So the most factored into all its prime parts is this. Okay, and it doesn't matter the order you write that parentheses in, but I always put it in the biggest power first, down to the smallest, and that's standard math classes. Okay, so for the next one, I'm going to switch back to blue here. The GCF, the biggest thing they have in common is, well, they both have a 4. Oh, they both have an 8. They don't have the same variable. This is A's, that has B's. So I just take out the 8. And dividing by 8, I get 2A squared. Minus dividing by 8, 3B. Now, since they don't have the same variable at this level algebra, we're going to say we're done. Okay? We're only factoring things with one variable. That's it. Okay? Over here, we're going to say, okay, the GCF is, let's see, they both have 3, and they both have an R, and I think that's the most. But if we forget to take something out now, after we take out 3, we notice, when we looked at it, oh, it still has an R. So let's just say we only notice the 3 at first. So we take out a 3, and we get 3R squared minus 5RS. Oh, wait a second, they both still have an R. So now let's also pull out an R. So out front is 3 times R times parentheses, or just 3R. And then inside, we now took out the R, so there's 1R left here, minus that R canceled out, 5S. So that would be as far as we go. Again, 2 variables, we're going no further. And then let's actually practice using the Xbox method. So again, the setup is most important. So the very first thing you do is, here's my Xbox, first term, z squared, last term, 16. Product is first times last, positive 16. Sum is middle term, signs matter, negative 8. Okay, we set it up. Now I'm going to go ahead and try and find that. Okay, so it's 1 times 16, 2 times 8, 3 doesn't work, 4 times 4, I'm done, because now the next number, like I have 4 times itself, these are getting bigger and these are getting smaller, so the next thing I would get to is 8 times 2. So once we get to 4 times itself, everything after it will be a repeat. So it's one of those 3. I know the product is positive, so the signs are the same, and they add to make a negative, so these must both be negative. So when I add the 2 negatives together, I get 8. That must mean it's this, because added together, that's 8. Added together, this is 10. Added together, it's 17. So it's negative 4 and negative 4. Multiplied, positive 16. Added, negative 8. Great. So that's what that middle term started as. It was minus 4z minus 4z. And when combined, it was the minus 8z. So we did split it up. Great. And now we just take out the common factors. All right, so now in a different color, I'll pull out the common factor here, keeping the sign. So negative 4. Even though they're not both negative, I just always keep the sign of the first box. So these only have a z in common, and I keep the positive. This is positive. They only have a z in common. This is negative, because the first box is negative, and they have a 4 in common. So it should be z minus 4 times z minus 4. Let's double check. Z squared minus 4z minus 4z plus 16. That's z squared minus 8z plus 16. Perfect, it worked. Okay, let's do another one. So again, setup is most important. So let's do product here, sum here. The sum is positive 2. The product is 3 times negative 1, so negative 3. Setting up my box, and here's a common mistake. People should just put the last term down here, but kind of common is instead people accidentally put the product in there. That's a pretty common mistake, okay? So anyways, we're going to put the first term, s squared, and the last term, negative 1. So now let's search. Okay, what are those going to be? Well, the only things that multiply by to make 3 are 1 and 3. And 1 has to be negative and positive. And in the end, there's more positives. So it's a positive 3 and negative 1. Double checking, right product, right sum. Great. So this is minus 1s and plus 3s. So factoring out the GCF, I get keeping the sign of the first box. They have a 1 in common. They have a 3s in common. These have an s in common. And keeping the sign of the first box, these have nothing in common. So I say they have a 1 in common. You can always double check. Do these two multiply to make that? Yes. Do these multiply to make that? Yes. Do these multiply to make 3s? Yes. Do these multiply to make -1? Yes. Okay, it worked. So our answer is s plus 1 times 3s minus 1. And you can always just multiply them together to double check. Okay, again, setup is most important here. So I'm going to say, first of all, just checking if there was a GCF. I didn't last time because it's not possible when there's a 1 here to have a number come out. And here there's no variable, and it was a 1 here, so I knew nothing was coming out. There's a number on all these, so I'm just going to double check. No, 5 and 3 have nothing in common, and there's no extra variables. So no, there's nothing to pull out. I just had to check because there was numbers in front of all of them. There's a coefficient there. Okay, so first term, 5b squared. Last term, positive 3. And then the product is first times last, positive 15. And the sum is negative 16. Okay, so starting to move a little quicker. That works out to be, let's see, product is 15 and they add, so that's negative 15 times negative 1. Okay, so that's negative 15b, negative 1b. So now pulling out with a different color, I get, keeping the sign, they have a 3 in common. Whoa, sorry, hit the button there. Pulling out from this column, we get they just have a b in common. These have a 5b in common. Keeping the sign of the first box, they have nothing in common, so I say 1. So this is b minus 3 times 5b minus 1. And again, you could just multiply those out to see if they work. Okay, I'm just scrolling down now. We're going to do another. Okay, so I purposely chose these ones because these highlight something else. Now, in general, right here, we'd say, you know what, that's not a quadratic. We're done. And at our level of Algebra 1 reviewing geometry, that's totally fine. However, highlight's a shortcut, okay, which is nice. And I'm going to talk about it right now with this problem. Okay, and then we can look at, this one's not special, but it's just an extra practice problem. So let's do 18 first. So let's set it up. Okay, they have nothing in common. This is made of 2's, this is made of 3's, and there's no variables. So we go, the product is 36, the sum is 12, and first term, last term. Okay, 4x squared and positive 9. This is a positive 6 and a positive 6. So I put in a 6x and a 6x. Pulling out what they have in common, I get 3, 2x, 2x, and 3. So our product is 2x plus 3 times 2x plus 3. Since they're the exact same thing multiplied together, you might see it as 2x plus 3 squared. Totally okay. Right? And then just checking the time, how much time I got before lunch. Okay. So this one you could do the same way. We just say this is 25r squared plus 0r minus 81. But you could also use a shortcut, which I'll mention. Okay, so standard method here. We got the product is huge number, and the sum is 0. And then the box, first term, last term. Okay, now we're going to be clever here. We're going to say, well, I know the sign's negative, so we got a negative and a positive. And when I add them together, they make a sum of 0, which means they must be the same. So I'm going to say, okay, well, that means this is a negative 45 and a positive 45. And the way I found 45 was just saying two same things that multiply together to make 2025. Square root of 2025 is, and we get 45. And so I put in a negative 45 and a positive 45, and I take out the GCF of each, okay? Now, before I figure out what those are, I just want to mention a shortcut. So there's a shortcut in factoring quadratics, which is if you ever have a two-term difference of two squares. Now, a difference of two squares looks like this. Difference means subtraction. Plural squares means I have two squares. So this is the difference of two squares. Okay, there's 1, 2 squares, and it's a difference. This will always factor to be a plus b times a minus b. Okay, that's a clever little shortcut. You didn't need it. We did it with the Xbox method. But if you notice that this was 5r squared, that's where the 25r squared came from, minus 81 is a 9 squared, that's where the 81 came from. So if we notice it's squared minus squared, then that will always factor to be 5r plus 9 times 5r minus 9. And that's just a nice shortcut. Okay, over here you'd notice this is, they have a 9 in common, they have a 5r in common, a 5r, and a negative 9. And oh my goodness, we got exactly that shortcut. So that's a cool shortcut that I won't require you to know this year, but it will save you time if you do know it. Okay, so what I'm going to do right now is I'm going to switch over to IXL. And the reason is I just want to show you a problem where you actually factor out the GCF and then use the Xbox method. All right, we're going, this is like 4th recording here. We're having a lot of technical glitches, so hopefully this goes smoothly. So we're going to go through a couple practice problems. IXL wasn't working, so I grabbed 4 problems we'll work through right now. Here's the first one. So again, the 2-step process to factoring is take out everything they have in common, then use the Xbox method. So I'm going to use pig to pull out the greatest common factor here. So what do these have in common? Well, this one's made of a 5 times 5 times x, if I factor it all the way. And this one over here is made of a 3 times 5. So the only thing those two have in common is a 5. So that's at most what we could pull out. And yes, there's a 5 in the middle term. So the most I could pull out is a 5. So I'm going to undistribute that, aka factor it. So I know the 5 comes out. And then the question is, what was there before I distributed that 5 in? So in other words, you divide each term by 5. And now if I double check, if I were to say like, okay, well 5 times this, and 5 times this, and 5 times this. And yeah, if you do that, you get 25x squared plus 10x minus 15. So that checks out. Now what I'm going to do is in blue, I'm just set up my Xbox. But I don't want to forget that factor of 5. Now, if this were an equation equals 0, I could just divide both sides by 5, and the 5 is gone forever. However, this is not an equation. If I say factor the number 6, you can't just divide by 2 and say it's 3. No, 6 and 3 are different things. You can't change the number. You could say this is 2 times 3, yes, but the 2 has to still be there, right? So here you can't forget that 5. If I'm factoring 6, I have to keep the 2 and the 3 to say 6 is 2 times 3. So I know my answer is going to be 5 times something if I'm able to factor what's left over. It might be that that's a prime number. Just like if I said factor, thinking off the top of my head, 9074, I'll factor that into 2 times 37. 37's a big number, but that's it. 37's prime. So that's the end. Can't go any further. So it could be the case that what's in here can't be factored anymore. And then you just say we're done here. Okay? But that's not the case in any of the problems we're talking about. Just telling you that could arise. All right, so anyways, let's erase that. And let's start. So just factoring what's inside, because the 5's already out, we'll say the product on top is negative 15. The sum is on bottom is positive 2, because remember the product is these multiplied, and the sum is the middle term. And then the first and the last go in my box. So 5x squared and negative 3. And now in green, I'll actually figure it out. So let's see, that started as a, well, if the product is negative, then one's negative, one's positive. So that's a, positive 5 and negative 3. Now what we've just really done, you don't need to know this or think about it, but I mean, what we really did is we figured out what was this middle term before it got combined. Before it got combined, it was plus 5x minus 3x in either order, and then minus 3. So that's what it used to be before someone combined it and only showed us the 2x. So now that we've taken it apart, we'll write those two parts over here, which is just what you had here, and then an x on the end. All right? And our last step then is just what do each of these rows and columns have in common. Now I keep the sign in my first box, so I know this one's going to be negative, this one's going to be positive, this one's going to be positive, and this one's going to be positive. And now I'm just figuring out what they have in common. The bottom row has a 3 in common. The top row has a 5 and an x in common. The first column has just an x in common. And the second column has nothing in common, so we say 1. And that's your factored parentheses. So now we have our end result is our GCF 5 times the inside parentheses factored becomes 5x minus 3 times x plus 1. And that's as factor as we can get because x to the 1 can't be pulled apart anymore. That's the inseparable unit there. Okay, so the next one will go same thing. What do they have in common? Well, they all have a 2. And this one's only 2 times 5. So the only other thing I can pull out is a 5, but 5 doesn't go into the other terms. So the absolute most thing I can pull out is 2 for sure. And there's no x's here, so I can't pull out any x's. So all the numbers that I can pull out are 2, and there are no x's. So my GCF is 2. Okay, so I write 2 times, and then in parentheses, what was there before I distributed it in? We just divide everything by 2. So we get 6x squared minus 13x minus 5. And if I distributed 2 into that, I would get the original. So great, everything's good so far. And then we factor what's in the parentheses, and my end result is going to be 2 times something times something. I can even put a box around it. That's going to be my answer. All right, so what I do then is I say, all right, well, the product, first times last, negative 30. The sum, the middle term, is negative 13. And inside my box goes the first term, 6x squared, and the last term, negative 5. So now in green, I'll separate that middle term and finish. So let's see, product is negative, so that means one's negative, one's positive, and that's, negative 15 and positive 2. It's 2 times negative 15, perfect, that checks out. So we got negative 15x and positive 2x. And now just pulling, first I'll say, I'm just going to write down the sign stays for each of the first boxes. So I already know all the signs. The bottom row has a 5 in common. The top row has a 2 and an x in common. The first column has a 3 and an x in common. And the second column has nothing in common, so that's a 1. Now, you could always just double check. Is 2x times 3x 6x squared? Yes. Is 2x times 1 2x? Yes. Is negative 5 times 3 negative 15x? Yes. And is negative 5 times 1 negative 5? Yeah, all those products worked out. So I'm going to take my blue and say 2x minus 5, 3x plus 1. Perfect. So just 2 last problems we'll do together. The reason I added these is now there's a variable in the GCF. So looking at this, let's see what they have in common. Well, the GCF, the only number this one has is a 3. And yes, it goes in the second one, so I can pull out all the numbers from the first one. And then they both have variables. This one's only got 1x, so the most x's I could pull out is x, or x to the 1 power. So now I go, okay, that's a 3x times, and what was there before we distributed in? So you divide it out. So the 3's gone, so you're left with 1, or just, x, to some power. You don't need to write the 1. And then if we take out one of those x's, there's still 2 there. Minus 27 divided by 3, so that's 9. And then x divided by x, all the x's get taken out, so there's no x's left there. All right. So now what we're going to do is factor that inside. Now, there is a shortcut. I'll mention it after. But let's do this in blue. First thing I'm going to do is I'm going to rewrite it like this. Plus no x's minus 9. So just so I'm clear on what my x box should look like. And again, I know my answer will be 3x times something, as long as I'm able to factor this further. So in my x box, we get the product, first times last, is negative 9. And the sum, that middle term's coefficient, is 0. And my box will be first term and last term, so x squared, negative 9. And then in green, let's see. Oh, well, that's a positive 3 and a negative 3. So we get 3x and negative 3x. Again, keeping the sign from each of the first boxes here. What do they have in common? Well, bottom row has a 3 in common. Top row has just an x. First column, just the x. And last column has a 3. So here is my product in blue. I'll put that down here. X plus 3, x minus 3, not forgetting the GCF. And I just wanted to mention the shortcut here, if you notice it, I'll do it in purple, is this is the difference of squares. So if you notice that this was an x squared minus a 3 squared, you could have right away said that's always going to be the first thing plus the last thing times first thing minus the last thing. The general formula is a squared minus b squared for difference of squares. We'll always factor to be a plus b, a minus b. That happens enough that it's useful to remember, but you absolutely don't have to. The Xbox method will work for every single factorable quadratic. Okay, going over this last one, the GCF here. Well, this one's only made of 2 times 2. So a 2 does go into all of them, but more importantly, a 4, both of those 2's could be pulled out of every single one. So the full 4 comes out. That's all the numbers. And then there is an x in every single term. So how many x's can I pull out? Just 1, because the last one's only to the 1 power. And so we say, okay, so I pull out all the things they have in common, and what's left over? Well, the first term would just be an x squared, and then plus 4, and then 1x left over, and then minus 5, and no x's left over. Now the Xbox method for that inside, and I know the format of my answer is going to be GCF times some parentheses times the second parentheses, if it's factorable, otherwise we might have already been done. Okay, so just doing that inside. The product is first times last, negative 5. The sum is the middle term, positive 4. And then in my Xbox goes my first term and my last term. So the x squared and the negative 5. Okay, now in green I'll say, well, the product is negative, so one's positive, one's negative. And that's a positive 5 and a negative 1. So positive 5, x, negative 1, x. And so, keeping the sign of each row and the sign of each column being the same as the first box. The bottom row has a 5 in common. Top one has an x in common. First column, x in common. And last one, nothing in common, so just a 1. And there we go. We've got x plus 5 and x minus 1. So hopefully that helped, and good luck factoring.